Welcome to the IMGeo CityGML relay using FME. I'm Dean Hintz from Safe Software, and I've been collaborating with Hans van der Marel from Red Geographics. We'll do a quick intro to Safe and FME, and then get into how FME supports 3D and IMGeo and the relay itself. Safe Software is based in Vancouver, Canada, with about 100 employees. And we have partners and users around the world, including many in Europe. We got started with file format translation, CAD to GIS, and then expanded to raster, database, XML, and now extensive support for 3D. We quickly learned that the tough problem implied in the translation is data transformation to reconcile source schema with the destination schema and the geometry and attribute manipulations that are required to do that. And core to this is schema mapping, schema transformation, and so we really pay close attention to how to model the semantics. Our central tool for architecting data transformations is FME Workbench. You drop in the data sources you want to extract from on the left, and then you can define transformation steps for manipulating geometries, attributes, and then ultimately map that to the destinations that you want to write to and map the schemas as required. An example of this is IFC to CityGML. You can see the source IFC feature types on the left, and then we convert from solid to mesh, build meshes into a surface, and then structure the data with the correct feature type, attributes, and geometry traits that CityGML requires. And then here's an example of viewing the output in Data Inspector. So that's another key tool that we have for exploring data, including 3D data, and looking at the attribute schemas and the geometry structures. Now, in relation to 3D and IMGeo, much of today's discussion is around CityGML data management, and talk a bit about 3D data generation, but I really want to underline a couple of other key capabilities of FME that relate to developing 3D workflows. One key one is automation. It might seem like a bit of effort to set up one of these workspaces just to edit one feature, but if you have to modify a range of features, especially across multiple data sets, then you begin to see the real power of FME. Also, format translation, both for 2D and for 3D data types like point clouds, BIM, that certainly helps. And we'll get into validation later, but I'll just mention database loading and extraction, and our enterprise web services, things like WFS, PDF, and KML to deliver data to clients in the structure and stream that they require. Here are some highlighted 3D formats and some other supporting formats like raster, exchange formats, and databases, and you can read more about these on our website. Now, to support CityGML, we have to reconcile between a typical relational data structure, flat data structure that you have in GIS, and the highly nested object-oriented one of CityGML. To do that, we define FME feature types that correspond with multiple model entities with a common schema, and then we build relationships through parent and child IDs, and then ultimately define the attributes and traits on the features and within the geometry that are required, such as LOD2 multi-surface. And here's an example of a building workspace for defining walls and roofs. And here we have extraction from LiDAR to build a surface model. Now, we've been supporting efforts to further geometry validation for validating 3D. There's an open source effort as well as that code embedded in FME itself. And what we're looking to do is automate detection of things like inverted faces, multi-surfaces that don't close, etc., so that ultimately we can automate quality checks on large data sets so that they don't have to be manually inspected. Here's what our transformer looks like right now. You can define a bunch of custom checks that you want, and in some cases repair. And so here you can see that we've detected an issue where the solid doesn't validate as solid because of a bad surface normal. You can see that in the center of the screen there. And once we detect it, then we can repair. So in terms of example 2D to 3D workflow, we'll see IMGeo 2D data in a minute, and in order to make a 3D data set out of that as a sample, we converted the 2D to 2.5D by draping on a terrain model, and we generated buildings, 3D buildings, by extruding building height to the difference between the surface and the terrain model. And here's an example of surface generation component of that workspace where we're draping. So here was the 2D IMGeo sample data set, and here we've generated a 3D equivalent, and zooming into one of the buildings showing some of the geometry structure. So in the relay today, shortly we'll look at opening and inspecting IMGeo data, and then various edit operations like editing building height, road width, and removing a building, changing the underlying surface designation, and some texturing examples. And then we'll wrap up with validation and a brief discussion on some of the challenges and lessons learned. For the first demo, we'll take a look at how to open and inspect IMGeo CityGML data. We'll have a look at the standard 2D relay dataset, as well as an IMGeo 3D dataset version of that, and do some zooming, panning, and feature inspection, including looking at the IMGeo and CityGML schemas. To view the data, we'll open it up in the FME Data Inspector. This is really just an open operation. We don't have to do any special import. We just have to choose CityGML, one of close to 300 formats that we support, and make sure we choose the ADE schemas for IMGeo. Click OK, and it just takes a few seconds to bring that in. And we'll see the layers on the left and the feature attributes on the right. So in this case, both CityGML and IMGeo feature attributes like the local ID. So here we have a 3D version of the dataset. Comes in plan view initially, but we can select the 3D view and the pivot tool so that we can actually zoom in and pan, and you can look at the data in 3D. And you'll see if I select building object, there are some attributes there. Let's fly over here. Have a look at some of the water areas. So you'll see in this case there is the CityGML class for that feature, water loop, and the ID, as well as some traits that are specific to IMGeo. And also if I go over and have a look at a building here, there's quite a few more CityGML fields specific for buildings, and then the IMGeo attributes as well. So that's briefly what opening and viewing and inspecting IMGeo CityGML data looks like in FME. And just to note that we did see a 2D version as well as a 3D version of the data, and we were able to inspect both the IMGeo and CityGML schemas. For our second demo, we are going to edit a building. We're going to edit the size of a building. To do that, it's a 4-step process. First, we have to select the building based on an ID, extract the existing elevation. We scale that by 2 times for vertical exaggeration, and then offset by the Z difference to bring the building back down to the original elevation. In FME, the tool we use to do data transformation is called Workbench. And as you can see, we have the data sources on the left side. So this is the original IMGeo relay LOD1 data for the buildings. And then we have the output, the data output in the destination. And in between, we have various process steps that transform the data. So you can see here's where we select building ID in the test filter. The bounds extractor gives us the original Z elevation. And then the scaling here, we don't do any scaling except for Z, where we have 2 to double the elevation. Extracting the new bounds. And then we can offset by the difference. And this is something that's new in 2012, 2013, where you can actually put the formula as a parameter. You don't have to have a separate evaluator for that. And we can go ahead and run that and see the output. And one big advantage of this approach is that while sometimes it might take a little bit more work to set up the data flow, this scales very well. So you can apply it to many different feature types from the same data set. So you can operate on many features at once, or in fact on many data sets at the same time. So it applies well to automation. So let's have a look at the output. LOD1 edited with the data inspector. Let's take a second for that to load. And we can pan over to that particular building that we just edited. And we can see that in fact the building is twice the height that it was for the building that we selected. Before they were all the same height. So that's how we can edit an individual element within FME. Next, we're going to look at an example of how to alter terrain, in this case broadening a road by removing a pavement edge. We've got 6 basic steps here. We need to select the sidewalk that we want to widen the street into, and we have to convert the features we want to merge from surfaces to polygons so that we can use the dissolve tool, and then we do a join of the attributes and then convert back to a surface so we can write out to the IMGeo CityGML. Now in FME, the way we do that again is with the workspace. And you can see here we've got the basic steps in what we call a bookmark, which is a group of transformers. First step, we select the street and the sidewalk based on their GML ID in this case that we want to merge together. Here's the geometry coarser to polygon. Then we have the dissolve tool, and then we merge the attributes together. And finally, a face replacer, and in order to support CityGML, we have to change it back to a surface, so set the LOD name and set that as on the geometry itself and write it out to CityGML. Now we can have a look at the output. Here you can see the original traffic area for this, where the sidewalk is, and then this is the sidewalk that we're going to merge into the traffic area. And then if I turn on the output, you can see that in fact that merge has taken place. So I can turn off the background. You can see that the road includes now the area that used to be that sidewalk. So that's basically it for the third demo, altering terrain. In this demo, we're going to remove a building and then reclassify the underlying terrain to wasteland. To do this, we have a relatively simple workspace. We just read plants and the other feature types. They just go straight across, and then we read the building parts and we check for the individual building that we want to remove. And for that one alone, we divert that over to plants because we decided to use plant cover for the wasteland since it didn't seem to belong under buildings anymore. So all the other buildings get written out to buildings as before. There's some building related attributes that I have to remove from some trial and error, and also we define the on-biguroid wasteland, and we set code space to the value that was prescribed. And we also decided to set the target URI to vegetation. Okay, and then in the output, you can see from the source data, if I only select buildings, you can see here, this is the building we want to remove. And in the output, in fact, that building is gone. So if I look at buildings only, I can see that that building is no longer there. Those are just the water areas. And if I turn vegetation on, plant cover, we now have this wasteland polygon defined instead of a building in the same location. And here's the, I cannot pronounce that, but the other terrain and vegetation URI. So that's removing a building and reassigning the underlying terrain classification. Another demo we felt would be particularly informative was the text string demo. We decided to use the LOD2 Gebauen dataset, and also we thought it would be interesting to also do both orthophoto text string of the ground surface and roofs, as well as a photo text string of the walls or the vertical surfaces. So let's have a look at how that went. Here's the workspace that I used to do that. We read the ground surface, and I generated a tin between the ground surfaces because in this particular file the ground surface is just the footprint of the building, and so I wanted all the ground surface between the buildings to give it more context with a hull accumulator. And here the key is the appearance adder, which adds the GeoTIFF orthophoto to the tin. And here you can see that we're using from top view as the method. And the next step was texturing the roofs. So similar process, except we actually had to chop up the orthophoto one appearance per roof. And so you'll notice that we have to group by GML ID. And again, we're adding the appearance from the top. And lastly, for the walls, it's a little bit different. We're using a JPEG this time, which is a side shot or side photo of the wall. And for a typical apartment, calling it apartment wall. And here we use texture mapping of surface normal. For the output, have a quick look in Data Inspector. This is the input data set, and here's what it looks like in the output. And as you see, we can zoom in a little bit, and it becomes more apparent what this looks like. So you can see the roofs are textured. There's the area between the buildings as well as the wall texture. And of course, we can click on individual features to get the attributes for the roofs, for example. And just for fun, decided to also output to 3D PDF. And the nice thing about this is you can see it's a lot more responsive. CityGML may be a great exchange format, but it isn't always the best in terms of interactivity or as a client format. So it's always worth keeping in mind when you have data streaming applications that it might be, when you have a large number of users who may not know much about CityGML, you might want to offer the option for things like PDF, 3D PDF, or KML. So that's basically it for texturing, using orthophoto for ground surface and roofs, and a wall photo for walls, and exporting to CityGML and 3D PDF. The last and perhaps most important demo that we have is the schema validation. There's not much point in producing CityGML or updating and editing it if no one else can read it. So we have to make sure we comply with the required schemas. With FME, each of our edits was performed by a workspace that read and wrote to CityGML, IMGeo CityGML. So we don't have to do a global export. We just take the output from the last edit stage, and that's what we need to validate. So we have two tools that we use for validation. FME has an XML validator transformer based on the Xerxes library, and that can do both syntax as well as schema checking. And then there's the validator that comes from GeoNovum for the purposes of the relay. And let's have a quick look at each. Here's a workspace that validates both syntax and schema. And you can see here we can choose syntax only, or we can validate against a specific schema, CityGML here and IMGeo at the bottom. And here we're just validating one of the, I think the first edit stage was the building edit. You can see that it passed on each of those. Now, in terms of the GeoNovum validator, this is our final export stage, or I guess you could call it final export. It's the output of the last edit. And you can see here that we're not passing, and the reason is that the same reason keeps getting repeated. There's only one error, and that it's because of it's expecting two-dimensional coordinates. So it's getting an odd number of positions, and therefore can't interpret that as 2D. So it appears that GeoNovum Syntax Checker only works for 2D data, and by default we always write out CityGML as 3D. So to deal with that, we created a workspace an FME workspace. All it does is use the text line reader and writer and replaces the z equals 0 values with blanks, so basically deletes the z zeros, and it changes SRS dimension from 3 to 2. So with those basic changes, it's just an extra workspace we have to run. Then if we upload that, you can see that everything validates. So we were able to validate successfully with that additional modification on the output. So to sum up then, we did pass the validation when we did that modification. So, but that might be one thing to look at with GeoNovum's schema checker, because once we get into 3D IMGeo, clearly it will need to work on 3D data. And the other thing that we came up against with the September data was that the source data itself did not validate because the GeoNovum checker can't handle X-link href. So I'm not sure how important that is. And once we found the October data, that was no longer an issue. So to sum up, the output of the edits, we were able to validate against both CityGML and IMGeo schemas, with the one caveat that the 3D data we had to modify to 2D to pass IMGeo's checker. Okay, just now a few quick words about lessons learned, and then we'll get into some conclusions. We've already talked about the GeoNovum validator, 2D versus 3D. In regards to FME, we did come across a few relatively minor issues. One was the label type not propagating correctly, reading but not writing due to some of the complexities of that nested structure. There was one or two namespaces that were altered, so we'll have to make sure we preserve those. Veg, for example, to CityGML class. The EPSG for the relay dataset wasn't automatically picked up, so we support it but have to manually set it. And the ability of our CityGML writer to write 2D data, that's something we'll look at. So in general, we are working hard to make sure we support IMGeo and CityGML, both reading and writing, and we'll continue to improve FME in order to better support that. And if you encounter any issues, please let us know. So we've already talked about some of the highlights about how FME supports 3D and IMGeo. So as a quick review, today was mostly about CityGML data management and a little bit about building 3D from 2D just in the data we inspected. But I'd also like to stress that one of the real benefits of FME is not just the ability to edit one or two features, but to apply a data transformation to an entire range of features, or even a number of data sets at the same time. And of course, our format translation for things like point clouds, raster, BIM databases definitely helps with making the ability to build 3D data sets from 2D. And FME server, of course, is a way of scaling that capability and also producing outputs from your CityGML that the wider world can easily consume. So I won't get into too much detail about what's coming in 2013, other than to underline that it's a really good idea to be using the latest beta or the 2013 release when that comes out, because there's a lot of new things coming which will support 3D processing better than what we can even do now. So to summarize, we saw opening and inspecting 2D and 3D IMGeo data, both the CityGML and IMGeo schemas. Several different edit operations, such as editing building height, road width, and removing a building, and a couple of different validation methods and issues. And how FME supports both 3D and IMGeo. So just a few resources there. You can look at our website, the FMEpedia site, which is our knowledge base, a lot of examples there, FME channel on YouTube, and of course you can always contact support. And a thanks to Hans van der Merwe, who helped us put some of these demos together. And you can always contact us directly or support. And there's a lot of other additional resources available. So we are looking forward to hearing from you, any ideas you might have on improving FME, and we look forward to supporting the best we can the IMGeo community working with 3D data. Thank you for your time.